Hello folks, welcome to this week's data science dossier. It's a bit different. I'm going to largely make it up as I go along. we, we've been looking at different architectures that are available and, you know, what's out there in terms of data fabrics, data meshes, all that type of stuff. And one of them that's it's steeped in history in some respects, but it's also reasonably new in terms of the fact it's been revamped and just relaunched from Canonical's perspective, is their data fabric offering. So what we're going to do today, or attempt to do, is take their data fabric and deploy Spark and Kafka into a Kubernetes cluster, stand that stuff up, and see where we get to. We're going to work through a lot of the, we're going to work through a lot of documentation together, figure it out, see where we get to in terms of a deployable platform, see how easy it is, see how fully fleshed out the documentation is, see if it's something that we might be able to use in a sort of production environment. So, without further ado, finding the right buttons. I told you it'd been a while. Okay, so what I want to go through is a bit of what the data fabric is, what it consists of, how I remember it, because I was a little bit involved. There is a little bit of history here with some of the stuff I did with Canonical a few years ago. And so we'll go through their website, see what it's about, and then we'll go and try and chuck that into a cluster and see if the documentation makes sense, so people can get up and running, can get going, and get deploying data solutions with Spark and Kafka into a Kubernetes cluster. So the Canonical data fabric itself, the website goes through a bunch of support options, what you've got available, and what's deployable. So we'll start at the top because it's not all about Spark. So the data fabric currently consists of, and I suspect they'll add more to it, but there's an awful lot of stuff that we use here on a regular basis. So we've got Postgres, MySQL, MongoDB, Spark, Kafka, and OpenSearch, which for a lot of data platforms is, the crux of what you're going to deploy quite often. If you want to do unstructured data processing, Apache Spark has obviously been around for quite a while. If you want to do stuff that's more traditional data warehousing, then you've got Postgres, MySQL for more traditional warehousing setups. If you want to do document delivery, you've got MongoDB. And if you want to do large-scale search platforms, then you've got OpenSearch, which, if you've been around for long enough, you'll know is a reasonably hostile fork of Elasticsearch when it all kicked off over on AWS, and Elasticsearch weren't too happy, and then AWS started OpenSearch, and anyway, that's all by the by. So, so from a platform perspective, the core parts, the core pillars for a lot of what you would try and do with, from a data processing perspective are here. Some of the stuff that's sort of then wraps around it in terms of AI and ML stuff. There's also offerings that you can plug into this. It feels like they're missing a few sort of more streaming stuff. Obviously Kafka's there and you do get Spark streaming, but it feels like there's a little bit missing from that, and also possibly like tacked on storage and stuff. I don't know. We'll sort of delve into that as we go along. But it's a nice start. And then of course, because it's supplied by Canonical, what you get with it is a whole bunch of support. So if you deploy this stuff into your cluster, you can get support from Canonical. You get, as they point out, an integrated system. So Canonical, for those of you who don't know, also make the Ubuntu operating system. And so, you get a lot of operating system support that comes with the platform itself, I would assume. And so, from, as it says here, Ubuntu Pro's compliance and security features, if you want to deploy this into a sensitive, data infrastructure environment, then you have that availability. And then you've got hybrid and multi-cloud ready. I don't know how much that actually appeals to people these days. The sort of hybrid and multi-cloud stuff has dissipated quite a lot, mostly because of the sheer amount of effort. But it was one of the things. So when we were doing like the Juju stuff back at the start, the ability to be able to wire things up across Kubernetes clusters, different cloud environments, and have these relations where they were aware of each other and could do things across these environments without a load of extra engineering was a nice selling point, I felt. But, in terms of general deployments, multi-cloud, for the majority of users, is probably not, a massive concern and consideration. And then as we go down their front page, we'll get off this in a minute, but we've got the ability to deploy this stuff into a bunch of different targets. It does depend on the charm and the piece of software you're trying to deploy to where it can go. But, you do have the ability, if you're building the software with the operators, to be able to deploy this stuff into a range of different different environments. And so you can deploy stuff into OpenStack if you're doing on-prem, telcos and that type of stuff. AWS if you want to stick it straight into the cloud and get a whole bunch of scalability off of that. LXD, for people who don't know it, is lightweight VMs that the LXD project, again stewarded by Canonical, allows for deployments of that stuff. Azure, and then of course Kubernetes, which is what we're going to look at hopefully today. Alex says, "Oh gosh, Juju, that takes me back." It is true. I mean, it's it's been a while, but Canonical use Juju to manage their own stuff. I believe it's it's dog fooding to a certain degree, and I have enjoyed using it in the past, but it has been a long time since I last used it, so we're gonna see how it goes. Yeah, okay, so let's move on. I'm not going to sit here and just look at the front page all day. We're going to start by looking at the Spark offering. And so outside of briskly scanning through these docs earlier, I haven't actually touched it for a good reason. I want to see, along with everyone else, how easy it is to get this stuff going. So again, we've clicked through to the Spark page, that offers up similar text to what we've just been looking at in terms of security and maintenance, the fact it's open source. For anyone who doesn't know, Apache Spark, with the name, is stewarded by the Apache Software Foundation, which is an open source foundation at US-based charitable organization that brings together a lot of different organizations in quite an open and inclusive manner when the projects have run well. No single company runs the project itself. The developers are supposed to come along as individuals as opposed to being on the company dime. Of course, features and stuff do get built into these platforms depending on what the developers pay to do. But it's all permissively licensed and allows for, the users to be able to use this software knowing that you can deploy it pretty much wherever you want without running afoul of any licensing issues. And that's the Apache software, the Apache license. It allows you to do that and, ship it. And as long as you keep trademarks and stuff in place, then you can resell this software or, use this software with your solution to be able to allow for people to be able to build on top of it. So you take Spark here, you've got Canonical's data fabric, they give away Spark and support alongside it. Then you've got Databricks, which are, of course, a large Spark users and spend an awful lot of time improving and enhancing Spark. And so everyone can collaborate together. It doesn't mean that you don't have forks and people adding stuff on top of it, but the core product itself is, an open source collaborative environment that allows for different businesses to make use of the platform. Okay, so we're going to run, as it says here, we're going to run Apache Spark on Kubernetes, and you can, so we were looking, I mentioned earlier, from a storage perspective, and, here it says you can integrate it with Ceph. For people who don't come from an OpenStack background, Ceph is like the storage pool for, self-hosted storage that comes with OpenStack. Hold on. Yeah, OpenStack. I'm complete brain fade for a second there. But yeah, so Ceph is a storage pool that comes with OpenStack. And again, so there are a number of different Kubernetes flavors, and Canonical's is microK8s. I haven't used it for a while, but we're going to use it today. I more often than not use K3s for deployment stuff, but as the documentation is written around K8s, we'll have a look at that. I wouldn't mind trying this again on a non-Canonical cluster at some point just to see what it's like, but we'll stick with what's known today, and then you can integrate it with Kafka, obviously. So what can you achieve with Spark? Streaming of data. So Spark is good in two ways. You can do a lot of streaming data processing. You can also do a lot of batch processing. You can combine the two together. And so you've got a Spark streaming engine, and then you've got the more traditional batch processing engine. So depending on how your data comes into your environment, it may be high velocity streaming data coming through a Kafka pipeline, in which case Spark streaming allows you to capture that data off of the pipeline, stream it, into your platform, and you may not even persist it using Spark. You may send it straight out the far end, transformed into something else. That's definitely one way of being able to leverage the platform. The other way is that you might stream that data in and then persist it into a warehouse of sorts, or a quote unquote data lake. And so from a data lake perspective, again, you've got a few different storage engines. You've got Iceberg, you've got Delta Lake, you can just store stuff in straight Parquet, you've got Apache Hudi, and there's a myriad of different options that you can leverage if you so choose. That's entirely up to you. And the same with batch processing. You may have a huge amount of data sat in an S3 storage bucket, or somewhere on a bit of fixed storage that you want to then be able to process, transform that data into something else. So, Spark again is great for batch processing. So if you've got high volume data that needs to be processed and then exported to a different format, or back to the same format, but in a different transformed manner, then batch data processing is what Spark does. It's bread and butter. You've also got Spark SQL. So for those of us who are still not great at writing, Python-based or Scala-based Spark jobs, Spark SQL does allow you to run SQL queries over the top of your data that's coming in, or the data that's in. So you can spin up Spark, you can run select star from my JSON file, my Parquet file, my Iceberg storage pool. There's a whole bunch of ways that you can use that, which you can then create views off of, do more transformation. You can start to join these things together to create like a multi-step ETL process, which is sort of, it's what Databricks try and offer. They do offer, the ability to step through this stuff inside of a notebook environment. You can chain all these things together, creating views, storing stuff to Python variables, all that type of stuff. And then, of course, Spark does have the machine learning toolkit that we use at Altec as well. We're using Spark for data analysis and market basket type stuff, and so the toolkit for machine learning is pretty good. Of course, that way you can leverage the distributed nature of Spark while still using these inherently. You don't have to worry about the clustering and the push down and spread out that you might do if you were going to hand crank all this, but you can still leverage that for machine learning whilst distributing that across your cluster. So if you've got a huge amount of data and you split that stuff across your cluster, you can use the machine learning libraries to go and find that stuff where it sits, rather than having to bring it together and then run your machine learning stuff over the top of it. Okay, Canonical offer consulting services. It's probably useful to know. So, if you want to do architecture and design, software deployment, ad hoc consulting, Canonical offer it. Of course, you're watching me, so if you do need it, feel free to reach out. We can also offer similar stuff. But I'm not here for selling. I'm here just to dive in and have a look. So we're going to get started. Finally, he says, after 15 minutes of me going through what the website has to offer. And this is going to, like I said, this is going to be an interesting dive into how this stuff works. But I should probably offer up a little bit of terminology as well for those people who are new to all of this. So we have Juju, which is a infrastructure management platform, for want of a better term. It's a set of tools that allow you to interact with Kubernetes, AWS, all that type of stuff that we went through earlier. So that's what Juju is. Then you've got Snaps. And so for anyone who comes from a Linux background, and especially a Debian-based background, you will know about, apt-get, deb files, all that type of stuff. So what Canonical tried to bring along to help with IoT devices and more over time is the snap package format. Now, there's also a bunch of others that are Flatpak and so on. I'm not going to go into what they do, but Snaps basically encapsulates a package in a standalone environment. If you can make it super read only, that way it can I'm clearly bastardizing this, so go and do some research, but you can make them quite secure in the fact that they can't write to various chunks of the operating system, and they do rolling upgrades and stuff, which do also make people a little bit sad. But from a packaging perspective, they're a bit chalk and cheese. Some people aren't too keen on them. Other people rave about them. But they do a job. And so a lot of the stuff that you see coming from Canonical is snap package these days. And it comes in a few different varieties. We'll look at that because we've got to install microcates, but we'll see. And so, yeah. So the Charm Spark install, I think, basically sets up a cluster with some hooks in to be able to deploy things against Kubernetes. That's my understanding from a very brief look. As it says here, deploying Spark applications to Kubernetes has several benefits over cluster resource management, such as Yarn. if you're still based in the mid 2000s, I guess. So there are a bunch of ways that you can deploy Spark, but actually even before I came across the data fabric updates the other day, I was using the Bitnami Helm chart for Spark. It seemed to be a good way of getting the thing up and running with, not a huge amount of effort into a Kubernetes cluster. It does allow you to distribute that stuff without standing up individual VMs and then wiring the VMs up to a Spark master and all that type of stuff. So I agree that there should be an easy way, and hopefully this is it, to be able to deploy Spark to a cluster that reduces the complexity of it from a user administrative point of view, whilst allowing the data scientists to do what they want to do, which effectively is like process data science workloads. So yes, Alex is asking about Neo4j, Grafana, and Prometheus. Now, Neo4j, I don't know. They did used to be, and there probably still are, charms kicking around for Grafana and Prometheus. Whether or not they're Kubernetes specific, I don't know, but we'll have a look later because I've got the Charm Hub stuff open. So we're gonna dive in. We're gonna actually try and run some stuff rather than me just talking about it. And so we're gonna run through the tutorial on a completely fresh Ubuntu VM where I have done nothing. And so I will push a button. Let's see. Thank you, Alex. I forgot to I forgot to add the microphone to this scene. So there we go. Hopefully everyone can hear me again. Yeah, so we've flipped over to the Charm Spark tutorial. So let's see if we can run through this, and hopefully once the buffer catches up, everyone can hear me again. Because there is a few seconds delay. Thank you, guys. This is why I have the comments open, because I realize I make stupid mistakes occasionally. Okay, so the Charm Spark tutorial will run us through like the basics of installing this stuff. I have a VM here that I launched from Scaleway. All I've done is apt updated, apt installed, pip installed Jupyter Lab for later, just so we can test some stuff to see how easy it is to connect notebooks to it. I don't know how easy that will be or not. But yeah, so we're going to start by just running through the tutorial and doing the simple stuff. And so if I click the next step, so the first thing we're going to do, and as I said, this has got literally nothing on it. So the first thing we're going to do is set up microK8s. And so anyone who joined late, microK8s is a Kubernetes distribution that is stewarded by Canonical. As you can see here, and as I was alluding to a minute ago, there's a bunch of different packaging formats. They use Snap to manage microK8s. Now, one of the things that does allow is for rolling updates of this stuff to get pushed out. So it does have the ability, either good or bad, depending on which way you look at it, for these clusters to be upgraded autonomously. Now, that might make a lot of people a bit nervous, but that's the way it is. It's also called microK8s, and initially I think it used to be like single node only, but these days you can install microK8s onto like a bunch of different VMs and have them communicate like a normal Kubernetes cluster. So it's called microK8s, but you can very much run it at scale if you so choose. So whilst that's doing its thing, you can see now that it's installed a little snap package. Let's move my face over there. There we go. So we can see that it's installed a snap package. And so this is installed 1.28 stable. You can like tell it to install different versions. They're called channels. So Alex says switch off automatic updates on production. Now, last time I checked with snaps, you could defer the updates for a couple of releases, but you could never actually like completely switch them off, which is what made people nervous, which is understandable. Now, like I said, it's been a while since I've been involved in it, so they may have finally relented. But last time I checked, you couldn't switch off like, you know, snap package upgrades. You could just defer them for a period of time. The other thing it does as well is like a snap package can provide a number of different utilities to command line. And what you do is you alias these because they start with like microK8s dot something. So if I like now hit tab, you can see we've got like microK8s dot add node, add-ons config. These are all like executable, you know, things that you can do. But of course, it's a bit of a pain in the backside to remember to write microK8s before everything. So what the docs then tell you to do is a snap alias, which then basically makes, in this case, kubectl aliased to your bash shell so that you can run this stuff. So that should now give us kubectl on the command line. That's a good start. And then we're going to add a user to the microK8s group, which is me. We're going to make a kube directory, and then we're going to make that directory owned by the user. So just there we go. So you can see there's a kube directory that's been generated, and so that's going to contain kube config stuff when it gets ready. So we'll then make sure that microK8s is up and running, and as you can see, I haven't logged out and logged in. What's the best way of doing this? Probably a terrible way of doing this, but let's try it again. Got a new shell. There we go. So with the new shell, you can see that now microK8s is up and running. And from there, there's a whole bunch of add-ons and things that you can enable, which is quite nice. I mean, to be able to start a whole bunch of add-ons without having to go and look up how to install them is not a bad thing. And so you can see some of these that come enabled are DNS and Helm stuff, which is obviously, you know, sensible from a Kubernetes perspective. Some of the other ones that come though, we've got Minio, which is an S3 compatible object storage layer for Kubernetes clusters. RBAC for authentication and permission-based stuff. Storage, which is deprecated. There's a whole bunch of stuff, but you know that they're disabled by default. But it's nice to see some of the stuff that's there. So we're going to take the kube config and stick it into there. So let's see if I do kubectl get nodes. There we go. So we've got you know, one node that's up and running. It's only been up and running a short period of time, but you know, hopefully this will be enough for us to go through the demo. There's plenty of storage, so it should be all right. And then we're going to do microK8s enable DNS. I think it's already enabled. Yes, it is. There we go. And then we're going to do microK8s enable RBAC, which is not enabled, and that is the authentication and permission-based stuff for Kubernetes. And apparently now the microK8s cluster is ready to be used. So, well, hold on, let's go and have a look. So we've sort of got down the setup microK8s section. Let's see if I can make this a bit bigger for folks so they don't have to squint at the screen. Yeah, so we've gone through the setup microK8s section. Your microK8s cluster is now ready to be used. We've installed microK8s. We've got the kube config in place. We've got DNS, we've got RBAC. So we're now going to set up the Spark client snap. And again, like I said, snaps bring in a whole bunch of stuff. And if you're writing applications, you want something that's portable across a whole bunch of Ubuntu-based distributions. Snaps aren't necessarily a bad thing. So if I take that snap line and stick it into my terminal, again, you can see it going away. It's going to install a bunch of stuff. This one's a little bit bigger, so we'll just wait for it to download. Nearly there. As you can see, snaps aren't necessarily the smallest packaging solution in the world. It's because they bring in all their dependencies and stuff. But that gives us, the Spark client that's now on in our terminal. So the documentation here, I'll just scroll down so you can see the last of it. This will install the Spark binaries along with the Spark client utilities provided by the snap. As we see the following, Spark client can be used by cluster administrators who create and manage the Spark service accounts, and developers and data scientists who need to launch Spark jobs. Now, there's couple of ways to be able to do this. You can use Spark Submit, you can use PySpark and Spark Shell. They're all valid ways to launch stuff. We're going to use the CLI first, and I'm going to see if we can figure out, might go a bit south, but we're going to see if we can figure out how to connect to the Kubernetes cluster from the outside to deploy stuff. I will change pages in a minute. Question that says, I'm more familiar with kubeadmin. Do I need to use microcates for this from Canonical? Yeah. I haven't used kubeadmin in a long time. So yes, you do have to, like, if you're going to deploy this stuff into microcates. Now, I don't think, and this is what I was saying at the start, which is why I'd like to try this on K3s. I don't think there's a hard dependency on microcates to be able to do this stuff. So if you want to use K3s, if you want to like hand crank, Alex has a good blog post out if you're interested in completely hand cranking Kubernetes clusters and what have you. There's a bunch of ways that you can do this. This wraps a bunch of services on top of microcates, but there's nothing that we've done so far that, to my knowledge, is like Ubuntu or Canonical specific. You could do this on a different cluster, I think, is the answer. We might have to find that out another day. So Spark service accounts, which are normally like, just grant everyone everything to make life a bit easier. But they've got a utility that helps administrators apparently manage service accounts. So we'll see if we can figure out how that works. So you've got a service account registry and then a whole bunch of flags that can go after it. That will create a service account, which then gives you the ability to run Spark jobs against your cluster. And so for Spark job submission, hold on, let me scroll down so you can see this. In fact, hold on. Let me push that one. So for Spark job submission, a service account is needed in Kubernetes, belongs to a Kubernetes namespace. If you're new to Kubernetes, a namespace is just a way of segmenting workloads and processes and stuff to a certain use case. So you can have one massive Spark cluster and a whole bunch of different namespaces, and users can not see across namespaces, can see across namespaces. This is what the whole RBAC setup's for. It allows you to silo users into a specific namespace or groups of namespaces, that type of stuff, so that they don't wallop someone else's stuff, or if it's sensitive data and that type of thing. So for Spark job submission, we need a service account so that the operator knows what to run against. And it says that it takes the following command. So Spark client.service account registry create. And then there's a bunch of stuff. So we're going to take the demo and we're going to stick it into this terminal. So it says, Spark client dot service account registry. So this again, because it's a snap package, it's got the Spark client prefix to it. And then we've got create, and then we've got a username, a namespace, a properties file that's picking up from somewhere, I hope. Conf, and then hello, Brandon. Greetings to you as well. Spark app name, and then executor instances. I have no idea what's going to happen when I push return, especially because I don't have a Spark defaults.conf, but we're going to give it a whirl. Yeah. So I wonder if that's mandatory or not. Let's try and remove it and just see if it works without. We can always create another one. When in doubt, remove the thing. No. Apparently didn't like that one. Service account registry, create, username, demo user, namespace. Let's go back to the docs. When in doubt. I told you this was a fact-finding mission, so it may take a while. Could touch it. I could probably just go and find a Spark conf file from somewhere. What have I skipped through here? Create a new service account in Kubernetes for Spark job submission. As indicated above, the commands can take the following optional parameters. Don't forget to enable default kubeconfig access for Snap, otherwise it will complain about overdefined. We've got that. The following utility functions assume administrative permission. We've got that. Interesting. Well, let's see if it takes the default. So if I they're optional. So if I just like wipe out a bunch of this. We haven't created a namespace and we haven't created a user. So let's just do a bit of that. That seemed happier. Okay, we'll pretend that we've got it right, and we may have to come back to it. But it's created a service account registry entry, apparently. So we can try and run a job against it and see how far we get, I guess. I feel like, what's getting the service account? kubectl, get SA. Oh yeah, there we go. So we can see it's created a service account called Spark. Let's make this big for you. So we can then have a look at that service account that it's created. Rid of that. So it's created this service account for us, which we're then going to try and run a job against. So the next step in the tutorial then has us running Spark submit, which we may now have to like fiddle around with because we've gone and changed some stuff, but we're going to give it a whirl. So changing pages, we've moved on to tutorial step number 4, which is the Spark job submission to the Kubernetes cluster. So we have to pass in a bunch of stuff to make it actually go and run. Hopefully this runs out of the box. Again, we're going to find out. The command above uses the default Spark user, which is useful because that's what we've created. Following the example from the previous chapter, the command has two more parameters, username and namespace. However, since we've already set the same deploy mode defaults for the user, have we? I feel like the docs missed a step here, but maybe not. That parameter can be skipped. So let me copy that, and there we go. We'll stick that in here. So I didn't pull down the examples jar. Let's try that. So Spark examples jar name, and then we're going to pull this out and then try running this one and see what happens. So apparently in ops Spark examples jar name, there's something. Now, we didn't create the namespace, so that's going to be default. I can probably just leave it out, but let's just stick it in and make sure it works. And then I believe the username is Spark, as I didn't create the one in the docs. So we'll run that and see what happens. Apparently it's up and running, or it's doing something. Apparently it's pending. I should probably have started this in a screen session, so as I haven't, we'll try and quickly find out what's going on in a different terminal tab. Where's my... Here we are. So if I do kubectl get pods, yeah, so you can see here now it's provisioned these two pods that are up and running, only just been up and running. That's how quickly it was. So what that did, even though we hadn't actually deployed anything to the cluster, and now you can see they've completed, so they've shut down. The operator has taken the Spark submit job, submitted it to the Kubernetes cluster, spun up two containers to run the job, and then shut the whole thing back down. So the nice thing about this, which is different to the way that the Bitnami Helm chart works, although that does have like auto scaling stuff in it, the way that the Bitnami Helm chart works is you've got workers that are constantly provisioned on the cluster and just accept jobs. Now, that inherently comes with a couple of problems, potentially, depending on what type of tasks you're running, in terms of deploying workloads and the limit of workers that you've got on the cluster. So if you've got a variable workload that's doing a whole bunch of different stuff, you're going to need to have the ability to auto scale or deploy pods on demand, which is how the operator works. So I haven't looked under the hood, but like the Google used to have, and I think still have, an operator that you can deploy to Kubernetes that then manages that stuff. And it's probably working along a similar lines where you can deploy jobs using Spark Submit. It will then figure out from the deployed job what resource you require via the parameters that are in there. And then it will launch a pod or a number of pods to process the workload that's been asked for. And that's pretty nice, assuming you've got the capacity on the cluster. Obviously there's hard limits to some of this. But, if you're deploying ad hoc jobs, you haven't got a bunch of pods like, Spark workers just sitting there taking up, multiple gigabytes of reserved allocated CPU and RAM when they're actually not doing anything. They're just sitting there idling. So, from burstable jobs and that type of stuff, this is pretty cool as well. So I like that. That was nice, apart from the weird bit in the documentation. It was probably me, but yeah, it'd be nice if you could copy and paste that other command. But anyway, so then they've got another example where you can then use it for S3. As we said earlier, if you want to do a whole bunch of if you want to do a whole bunch of data processing, your data probably doesn't lie on the same node that you're executing your Spark job from. So, you can wire in S3, and this bit is definitely not remotely Canonical specific. You're just telling it where your bucket is and how to access through your S3 keys and what have you. That's any tutorial for S3 access on Spark will tell you that much. So that's generic stuff and will just allow you to do your thing. A couple of other examples. Oh, here's a sparkdefaults.conf, which we could probably have done with on the page before to deploy this stuff. Anyway, Alex is right. Maybe I could have touched an empty file. But anyway, so if you want to deploy some stuff and then have S3 in the back end, what have you, there's a good pattern here that you can then go and use that will, allow you to do your thing. Of course, as I said earlier, Spark does have an interactive shell. You can also interact with Spark using PySpark. Depending on how you want to deploy this stuff, that will vary considerably. Invariably, I quite often use PySpark and just connect PySpark directly to the Spark cluster. Not entirely sure how that works yet. But we'll have a quick look at the Spark interactive shells and stuff, just because it shows you how you can go and chop stuff around live-ish. It will, of course, deploy more pods, allowing us to do stuff. So if I snap that button, we're going to start a Spark shell. So again, like I said, Spark in this context is a snap. I'm in the wrong shell, that's why. Spark client.spark shell. So because it's a snap, we've got Spark client at the start, and then we're asking it to run the Spark shell command. And that, if I have guessed correctly, interesting, it hasn't started a pod yet. It's working on it, I guess. And Spark session. So you can see that we've landed into a Spark shell. I am still curious. Oh, there we go. So we've now got these two Spark shell pods up and running. I'm also interested, just out of nosiness, sort of what they get allocated. So if I just take one of these, yeah, so the executor memory out of the box is a gig. It has 1 core. And then there's similar limits for the requests. Can't speak. There's similar requests and limits provisioned on the Kubernetes side. So, out of the box, these shell workers are quite small. I'm sure you can fiddle around with them to make them bigger. Hold on. Brandon says, have you used your Spark instance to work with things like Delta and Iceberg tables? When working with these snaps, how do you introduce support libraries, etc.? Which is a good question. And I don't know the answer to that question yet. Well, so going back to have a look, well, actually, no, because on the previous page we were looking and it was passing in Spark submit. So you can pass stuff in, classes and what have you, and jars as part of the Spark submit command line. That I don't think is any different to how you launch that stuff any other way. When I use PySpark, and this is not within a snap context, but I think the answer would be the same. I can pass in ops that then go and grab jars from Maven Central that I want to be able to use alongside the PySpark job that I'm running. So if I'm running some, like I've got some stuff that writes data out to Iceberg, for instance. So I want to bring in a whole bunch of Iceberg stuff. You can submit that stuff as like PySpark ops as an environment variable prior to executing your PySpark job, and it will go and download that stuff. I'm assuming that Spark here will run in the same manner. It'll go and get that stuff, and then use that as part of the execution pipeline. So we're going to have a quick look at just running some stuff out of here just to make sure that it works and we have a functioning Spark environment. So if I go back here, this is all in Scala, and then we've got a similar one in PySpark. So actually, maybe we can fiddle around and see if it works in PySpark. So it's gonna do some maths for us. There you go. You can see it going away and doing its thing. So it chunks stuff up depending on the complexity of the job being asked, and will then store stuff and give us a output. So super simple Spark pipeline. Do not use this in production. But gives you a sort of indicator as to how it works. The interesting one, because I use it a lot more, is PySpark. So if I drop out of here and launch PySpark, this, for people who haven't used Spark before, you've basically got two engines to interact with Spark. You've got the Scala engine, which is based on the JVM, the Java Virtual Machine, and is, has been around for a long time and allows you to write, Java type jobs over the top of it in the Scala syntax. And then you've got PySpark, which is a Python wrapper. I was going to say wrapper. It's probably a bad term, but it interacts with the Spark APIs using a JVM wrapper under the hood to take your Python and leverage it that way. And I can't speak with any great certainty, but I suspect more people use PySpark these days than use Scala. A lot of reasoning behind that would be just due to the ecosystem support that you get with Python, because that way you can leverage pandas. Spark these days allows for pandas workloads to be processed on it. There are some limitations with that, but then equally Spark has UDFs these days that use pandas to accelerate their UDFs. So it works both ways. That open source collaboration is quite nice. So I've created here a little function. Sorry, I should scroll down so you can see all this. Create a little function that's called square and accepts an int and will return a float. And then we're going to run this one. And again, you can see it going and doing a sum of squares. Yeah, I agree with Alex. I think, PySpark does seem to be a lot more popular. I think, there's a reason for it as well, isn't there? Is a lot of people come from a pandas background or a NumPy background or doing something that's already chopping and changing data with Python, because that's what a lot of comp sci degree courses, deal in. It's easy for people to wrap their head around. They can then go and write APIs using, Fast API or Flask or whatever, quickly and easily, to create like a data app that doesn't require a whole bunch of ecosystem support. And so, I think that way the transition for people to go from pandas to PySpark is a lot less, and you can obviously leverage libraries that you're already familiar with to be able to process that stuff. Anyway, so there you go. You can see PySpark working. I was wondering about bringing in more Maven stuff, but I'm not sure. Let's see if I can find some code quickly. Bear with me for 2 seconds. I'll see if I can find it. The only thing is, I'm not sure how you, like, I pass it in as an environment variable, I think, by and large, which may not be, it may not be too happy about that, but we'll give it a quick go. Yeah, so I normally, if I'm wanting to do iceberg stuff, for example, this will go horribly wrong if I try and do it, but I use this like PySpark submit args. That would normally happen before I've created the session. So I'm going to chuck that in there. We're going to watch this blow up, I expect. Because I don't even know, like, if I wanted to create... Yeah, I mean, in here, you've already got the Spark sessions. I don't know, like, there must be a way of being able to leverage that, because basically that will then go off to Maven Central and download the stuff that you want and say, this is how I write iceberg stuff. Cheers, Dan. Thank you for swinging by. Yeah, so there must be a way. I will endeavour to find out, and we'll come back to that at a later date. So common gotchas, make sure that DNS is enabled, make sure you've got enough CPU. That would make sense. Don't forget to enable default Kubernetes config access for the snap. We did that right back at the start. Make sure that namespace provided to Spark Submit is valid and the service account belongs to that namespace. That's probably pretty crucial for people who are doing this first time. Apparently there's a script called setup Spark Kates. That's interesting because I'm pretty sure we weren't told to run that. Let's have a look. Spark client. I don't know. It'll be around somewhere, but it's probably another documentation thing. When you're working with a Kates control plane URL, it would be useful to see an example. I don't know if there is one. It would be useful to see an example of how to submit an external job. I was hoping to be able to do that at some point, but I don't know. But what we are going to go, so we're going to move on because I appreciate we're already sort of an hour into this exploration. We are going to try and do some Juju stuff to add Kafka and then see if we can figure out how to get Kafka to connect to Spark and then read some stuff in. We'll see how this goes. You know, there's a lot to be said about how Juju can now go and deploy stuff. So the way that we did the Spark installation was like, well, it was all Juju free. So it was, you know, installing the Spark snap, which then gave us access to stuff where it understood where the Kubernetes endpoints were, and so allowed us to go and run those jobs. So now what we're going to try and do is use Juju to create a model which we can then deploy Kafka into, still in Kubernetes, and then try and flow some of that data from Kafka into Spark, which is a pretty, you know, regular use case that is Spark streaming's bread and butter if it works. So I'm going to run this and it's going to tell me Juju's not installed. So we're going to do sudo snap install Juju. I think you need the classic flag. So here we go. Anyone joining late, Juju is a systems automation tool from Canonical that allows you to deploy stuff to Kubernetes, AWS, a whole bunch of other places, and connect the dots, really. It's pretty cool in the way that works. Oh, apparently I didn't need a classic flag. There we go. So, so we're going to deploy... Here we go. Let's flip back to the doc so everyone can see what I'm doing. We're going to deploy the Kubernetes Zookeeper, the Kafka Kubernetes charm, and then we're going to relate the two together, and let's hope this works. Juju deploys Zookeeper Kates. Here we go. So Juju Bootstrap. So this takes me back. I haven't done this in years, but we'll give it a whirl. Don't mean to do that. Microcates. Juju can only work with strictly confined microcates. That's awkward because I installed it without it being strictly confined. Sudo snap remove micro. I'm absolutely guessing here, so let's try that. So we'll try and install microcates again, but remove the classic flag, because I don't know if there's no way to do it. Snap. Yeah, sudo snap install microcates. Let's see. What? So that doesn't make any sense. Let's ask Google. Juju microcates. Let's see if we can find a document that would explain this. Nope. Canonical, your documentation is lacking here. Juju deploy microcates. Really? Let's see. Juju deploy microcates. Channel edge. That's what I was thinking. Juju microcates register. Let's see. Yeah. Right, sudo snap install microcates. That one doesn't have a classic flag next to it. Oh, it's got a strict channel. Okay, let's try this. What are we on? 128. Oh, there we go. Just for anyone who's as confused as I am, I found juju.is/doc/sdk/setup your development environment, which runs you through installing stuff on a strict channel, which then hopefully allows me to bootstrap Juju. So we're gonna do this again, bleeding edge style. So this is installed a much stricter confined microcates, and then we're going to actually. I think that's all right. Well, okay. Let's try that one just in case. We've got one of them. Let's create one of those just in case. Let's see. Yeah, okay. We're getting there. We're getting back up and running. So let's try kubectl get nodes again. Okay, so we've got another node that's up and running. Now we're going to attempt to bootstrap Juju, and so we need to create a storage thing for it, and we're going to do Juju bootstrap microcates streaming Spark. Let's see if that comes up. There we go. That's looking happier, isn't it? So yeah, as you can see, there's a few interesting quirks in the old documentation. But this is basically now bootstrapping Juju onto the Kubernetes cluster. I wonder if I'm in here. Yeah, bear with me. Let's fix this one as well. quicker to log out and back in. So yeah, so we created this controller that's called Streaming Spark, and so that's created a namespace, and then it will install a bunch of pods into that namespace. There we go. So it's downloading the pods that are required for Juju to be able to administer your Kubernetes cluster, and then it says here we want to do Juju add model name. Now if I go back to where we were, this is called Juju add model Spark streaming. Let's go back here. There we go. So that wasn't right. Completely pasted the wrong thing. Let's try again. So Juju add model Spark streaming, and so Juju is now managing my Kubernetes cluster. Added Spark streaming model on MicroK8's localhost, and give us some credential stuff. Now we're going to try this again. So we're going to do Juju deploy Zookeeper K8s and see how we get on. There we go. So deploying Zookeeper K8s from Charm Hub. Charm Zookeeper K8s. We're going to have a look at Charm Hub in a minute. So if I do get namespace again, you can see it's got this Spark streaming namespace. So if I do like get pods, there we go. So you can see here it's running, well, they're coming online, these Zookeeper pods. They'll be coming to life. And so then we're going to do Juju deploy Kafka K8s, which will then launch some Kafka stuff. If we go back here eventually, there we go. So you can see how we've now got these bits coming online. I should probably just watch this namespace, There we go. So they're coming to life. You can see Zookeeper pods have now turned to ready state. And the Kafka K8s pods are initializing. There's a whole bunch of clever like hooks and stuff underneath that are registering bits with the Kubernetes cluster and making these relations, which we're about to get onto, available to each other. So Juju has this ability to relate pods to one another, and so this works quite well. The demo that they always give, which was quite an obvious one to show, would be if you had a MySQL database and you had a WordPress front end, you could do Juju deploy WordPress, Juju deploy MySQL, Juju relate MySQL and WordPress, and MySQL would then know to provision a database. It would know to provision the credentials for that database, and then allow for WordPress to insert those credentials into the right place, and then WordPress would be able to connect to the database without ever having actually manually created a user. The credentials being just transferred across, which is quite a nice way of getting stuff up and running. Kafka traditionally needs Zookeeper to run, so we're going to relate these two. And basically under the hood, you won't see anything happen here, I don't think, but basically that will connect the dots between these two so that Kafka then knows about Zookeeper, and Kafka will then be happy to go and do its thing. Then we've got deploy a test producer application to write messages to Kafka. So if I take this one, Juju deploy Kafka test app, and chuck it into the cluster. Let's go back, see if anything happens. There we go. So we've got this Kafka test app coming online. You can see how we've got 2 Zookeepers, 2 Kafkas, and 1 Kafka test app. And so, the way that you can use this is either just bring your own code and run stuff, or you can wrap your code into a charm and deploy your charm alongside all this other stuff. And so what we're going to then do is relate the Kafka test app with Kafka K8s. And that will then make Kafka test app aware of Kafka K8s, where it is, what the DNS endpoint is, all that type of stuff. and make them start talking to one another. So this will start, as far as I'm aware, start producing messages and inserting them into the Kafka cluster. So you've got to think of Kafka Test App as some service that's streaming data into your cluster. And then we're going to set up this. Let me scroll down. So to consume these messages, we then need to have credentials between Spark and Kafka, as I was giving the example with MySQL and WordPress. This is how the security can be managed in quite a seamless way. And so we're going to deploy the data integrator. And then it's got these like use extra roles of consumer and admin, and there's a topic which is Spark Streaming Store. I'm then going to relate the data integrator to Kafka Kates, and then we're going to run this action which is called get credentials. So you can like hook a bunch of shell stuff into this as well. I hope. When the docs are out of date. Juju. I think show action is the output, so that's not going to help. It's even wrong. Juju. Oh, there we go. This is going to test my Juju command line skills because it has been so long. Wasn't what I wanted. Let's have a look. Juju. Clouds, add credentials. So we've got here, just as I work through some of this, just so you can see what's going on. If I run Juju status, it tells us what model we're in. You can switch models so that you've got workloads deployed in different parts of Kubernetes where they don't clash with one another. You can see that we've got the data integrator, we've got Kafka Kates, the test app, and Zookeeper all connected with one another. And then we've got the units and the addresses to go and speak to them down the bottom. What I'm trying to do is run an action. So let's see if I can figure this one out. Run action. So if I do Juju actions, what were we running the action on? Not that one. There we go. So Juju run action. I want to see what actions are available here. Get credentials. That's right. So that's a good start. Well, so it's actually, they've just flipped it a bit. So Juju run action needs to be Juju run, I hope. There we go. So that's gone and run an action which is called get credentials on the data integrator and returned back to the command line. If I then find the right chunk. So then we're doing testpod.yaml. We're going to chuck this in here and save that. Oh, I should also point out with get credentials, you can see how it's outputted a bunch of stuff, and you've got like topics, you've got a password, you've got the endpoint. So you can see how these relations work, how they connect to one another. You know, there's plenty of communication that's available. And then if that has launched, we've now got, oh, image pull back off. That's not good. No, test pod. Charm Spark. Let's kubectl describe pods. Oh, I haven't deployed Spark into this one, have I? I don't know what that is. 341. Let's knock that off. There we go. Let's see if that's any better. Might need to destroy it first. Or do I have to? What's it called? Test pod. Remove, delete. It's been a while. Normally use K9s. Oh, it's already gone. What? Oh, it's up and running anyway. There we go. I normally use K9s. My kubectl command foo is lacking me a little bit on Friday. But okay, so this test pod is now up and running. And then it says launch PySpark shell. So we're going to do exit. Hold on. Let's just copy that. Okay. So we've got a shell inside of this test pod. We're going to do cd home spark. No, we're not. What's it? There is no spark. Okay. Who knows? Who am I? Demon. Let's go home. Make the cube. This will be fun. Let's see. Let's just rip that out. It's not going to be there, is it? Okay, cat.kube config pof. Stick you in. Where's the rest of it? Keep going. So if that worked, so that says run a snap. Okay, wasn't a complete explosion. So Spark client service account registry create username hello. Wild. So that's looking for kubectl. Still inside the pod. So kubectl, kubeconfig. That's not where I just stuck it, but fair enough if that works. It's actually got some stuff in it. Let's have a look. Oop. Yeah, I don't know why I had to create a kube config. That's in there. But this was the same problem we were facing earlier. Create service account is not happy. So let's back that out again. It's still not happy. All right, we'll leave it there because I've obviously been going for the last hour and a quarter, and that could turn into a debugging session that's going to take a while. So we'll go through the rest of the docs, and then because there's literally only this last bit left, and then I will probably create a blog post about how to do this final bit once I've figured it out, because it might be, it's not going to be entertaining for everyone to sit there and watch me debug a Kafka connection issue. So what you're supposed to do is create this service account, and then do a registry list, and then we can create a PySpark. Oh, there we go. That answers Brandon's question. So, like, if you're launching PySpark manually, at least, you can then pass in the jars via the packages CLI command. So I should stop jumping about. But you can see how you could pass in iceberg stuff there to allow it to do stuff. That would then launch PySpark. And then from within PySpark, you can then deploy a PySpark job. And so basically what this does from a Streaming Spark perspective is create a connection which uses the relation and the password that we looked up just previously in the terminal. Hold on. So that uses the information that's come from, if it's still there, here. So this password and that relation is what goes in there. And then looking at the next bit, it's then spark.readstream, which is kicks off a Streaming Spark job with a Kafka source, points to the Kafka bootstrap server, which again comes from the data that came from get credentials. So you could automate all this by leveraging the relations and stuff, but in here it's just stuck into the script. Connecting using secure TLS to ensure security of data in transit. Subscribes to the topic that was created via the commands we ran earlier, tells it to include the headers, and then loads it. And basically that kicks off the Streaming Spark job. And then obviously I don't know what's in that because we haven't seen it, but you can see here that we do get origin, which then loads up some data via a UDF, and then runs a simple count on the end and awaits termination, and then that's the job done. So we nearly got to the end, and I'm sure some of this, if I wasn't sat here on a call that had already been going for quite a while, we'd be able to figure out reasonably easily. But you can see how leveraging Juju and the data fabric can offer an alternative to spinning up Helm charts or leveraging Databricks or whatever you fancy on there. So, I think it has potential. I think the documentation could do with a few more bits and pieces. Also, how do I deploy external workloads to it? I'm sure it's easy enough to figure out. But, it'd be nice to just include some of that stuff in documentation. One thing I do want to just run through before we sort of get to closing on this is, the Charm collection that does exist. And so the Charm store, Charm hub, is where you can get all these things. And you can see here we've got Kafka, MySQL, all that stuff that lives inside of the data fabric offering. And there's a whole bunch of other stuff in here as well. You can deploy all sorts of stuff. But you can come in here and filter by platform. So if I say I just want Kubernetes stuff, Alex was asking at the start whether or not you could deploy Grafana and Prometheus. The answer is yes. So you could do Juju deploy Prometheus, Juju deploy Grafana. There's all sorts of bits and pieces in here, and they're basically used by Canonical internally, but you can create your own. If they're open source, you can commit them to the Charm store, I think, still. But, if you came in here and you're interested in how one worked, or if you wanted, I don't know, MySQL, come in here. You can see how MySQL works from a Juju perspective. It gives you a little command. You can do Juju deploy MySQL Kates. It will deploy a MySQL server from the data fabric collection to your Kubernetes cluster. If you want a different version, obviously we talk about snaps and stuff. Now they have like channels, and so Edge is bleeding edge. Beta is something that's getting close to a release. Candidate is a release candidate, and stable is stuff that you should stick into production if you're going to use it. But you can obviously, flick around from there. Let's see what else is in here. So they're the resources that get deployed. So basically the MySQL image and the version of it. You can see how different charms in the store relate to that specific charm that you've deployed into your cluster, and how they would, how you can interact with these charms in a sort of dynamic fashion. Not sure what libraries are these days. There's some configuration options and the actions that you get access to. So similar to how we were just looking at Kafka, you've got get cluster status, you've got get password, all that type of stuff, which you can then run. So depending on who wrote the charm, the actions and the configuration options will be different, but they'd give you access to be able to tweak and leverage the way that your platform works. So there we go. I wondered if I'd get through an hour and a half. I got through an hour and a half. Thank you very much for sticking with it. I did want to run through a couple more things just before we drop off. So from a data fabric perspective, there were some questions about whether or not you have to use Ubuntu stuff. The answer is probably mostly yes if you want support and that type of thing. Like I said, I'd be interested in trying to deploy this into a non-microK8s environment. See how it works. I honestly do not know if that would work or not, but it wouldn't be bad to try. That way, if you wanted to leverage it on K3s, whatever, there's potential for it. If you're interested in support, Canonical handily stick support stuff on here. I'm not selling their support by any stretch of imagination. I have nothing in this game, but they have a $50,000 fixed price solution architecture build stuff, and if you want them to operate your data fabric platform for you, then you've got a per VM pricing in there. So depending on what your solutions require, that might be a route to go. As ever, I am of course a consultancy, so if you want support for stuff like this, or data processing stuff in general, let me know. If you're in the data architecture game and you're interested in having a good old chat with some like-minded people, Alex, who's sat here on the call, sent the link out to his Slack channel earlier. Highly recommend you join that because it's good for jobs, networking, and all the other stuff. Like I said, thank you very much for joining. I hope I can do some more of these. If you want me to do stuff about certain topics or whatever, let me know. I'm happy to geek up on certain topics to find a way to help out people in the industry. Some of it will be more technical, some will definitely not be me just sort of seat of the pants figuring out how stuff works live. I figured it might be a bit of fun as it's Friday. Other stuff will be sort of more tuned and polished, if that's your type of thing. But like I said, thank you very much for swinging by. It's been a lot of fun. Let me know in the comments or send me a message, DM, Instagram, Slack or whatever, what you thought of it. And I'll be back at some point, not too distant future with more. Thanks a lot.